what what this is going to get us to do is learn notation for writing and interpreting values for x, multiple values for x, okay, usually infinite solutions. Um, what happens is, so this is going to be a way that we write domains and ranges as we move through the functions of this course. Um, it becomes, as you move into higher level math courses, this becomes like the number one way of presenting solutions. So we need to be able to understand this notation, okay? And what kind of stinks about mathematics is if we were to go through mathematics and we were to write answers and just text in general, like notes and stuff like that, without math notation, and we were very specific, it would be a lot easier of a course, okay? Obviously, it'd be a lot more writing, and the textbooks would probably be 2-3 times as thick, okay? So we as mathematicians, I always had a professor says mathematicians are lazy. Mathematicians are lazy. They don't want to write a lot of things out. So what they do is they create shorthand for writing extensive things. Does that make sense? Okay. You guys know what shorthand is? Okay. So secretaries a long time ago, before they had like typewriters and stuff like that, they would sit and they would be the scribes for like CEOs or bosses or like whatever when they were having a meeting, and they couldn't write every single word out, right? If you were trying to write every single word that I'm having right now with you, you were not going to get them all right, okay? Especially if it's two people talking. So they would have shorthand symbols, and words were, they actually had like my grandma was a secretary, so she had like this booklet of like, and it was huge, of like shortened words, abbreviations, and that kind of thing that she had memorized, and she could transcribe a conversation between two people without missing a single word from either person. But she was really the only one that could then read it. Does that make sense? Because she knew the notation. Same thing kind of happens in math. We have a notation that mathematicians know. If you don't know it, it's going to be hard to read what they're trying to tell you. Does that make sense? Like if you guys showed me something in Spanish, because of all the accents and notation and stuff like that, I'm not going to be able to read it. I know some of the words, but I'm not going to be able to understand what you're trying to imply. Like if I'm in English class and I see an exclamation point, okay, and I don't know what that means, there's implications to that exclamation point, right? It means something to the person that's reading, okay? Question marks mean something. If I don't know what those mean, semicolons, colons, if I don't know what those things mean, then I lose context, right? Okay, I lose what they're trying to talk about, what they're trying to convey. So the same thing happens in math, okay? I think, in my opinion, if I would have been introduced in high school to notation in a much more elaborate way, a better way, then I wouldn't have had the difficulties that I did experience. I think I could have maybe focused on other things instead of trying to learn notation on my own. So when we talk about notation, there's a couple different ways of talking about notation. This here is called inequality notation. Sometimes we'll refer to it as like set. It's called set builder notation, and we'll get into greater detail. You don't need to write that down right now. But you guys are familiar with that stuff on the left-hand column, right? Okay. Well, that's kind of a pain in the butt to use. Okay. If you think about typewriters back before we had word processing, even if I try to put greater than or equal to in Microsoft Word, you guys know how pain in the butt that is to find where that is? It's not a keyboard function, right? Okay. You got greater than and you got less than, but you don't have greater than or equal to. Okay. So that's a nightmare to actually type in. You got to go into the symbols and find it and all that kind of stuff. Think about typewriters. You were stuck with what the keys were, okay, and those were not on typewriters, okay. So this was kind of messy. You guys know how to graph that, don't you? If I'm on a number line, let me see here. That's a very big number line. Let's see. What in the world? Huh. I swear my computer. like my Control Z doesn't work. Every once in a while, I'll start typing, and it'll be typing normally, like it's supposed to, and all of a sudden, all my keys turn into shortcuts, and I start closing windows down. I start opening stuff. It is nuts. So I guess we'll just draw. All right. So if we have my number line here, and I've got 5 on it, right? And we said X was greater than 5. So you guys remember what kind of dot you use? Open dot for greater than. And then because it's greater than 5, I'm going to shade to the right, correct? Okay. So that's one way of presenting what this means to us. Would that be pretty hard to do in a word processor or a typewriter or something like that? So we have what we call interval notation. Okay, and this becomes very critical. This is, like I said, probably one of the most important things that we're going to talk about early on, because after we learn this, probably 80 to 85% of your questions and your answers are going to be either expressed in question form using interval notation, or you're going to answer in interval notation. Okay, so if you don't understand this, you can kind of see it. That's going to be a big issue in getting solutions correct. Okay, but interval notation, the way we do this, it's going to be a set of 2 numbers. Okay, and the first number, the way we're going to decide this is we're going to actually take. It's easier initially if we have our graph first, so we have a mental image of our graph. Okay, and I'm going to take a vertical bar. And I'm going to start dragging that vertical bar through my graph. And I'm going to stop when I see that it touches my first solution. And it would be right to the right of 5, correct? That make sense? That open dot on my number line means if I were standing on my number line, I could walk up to 5, but I could never stand on 5, right? Does that make sense? I'd fall through the number line because 5 is not a solution. So I can walk right up to 5. I can get to 5.00000000000000001, but I can't get to 5. I can't make that next jump, right? Now, so the first solution is a 5, a decimal point, and then an infinite number of zeros followed by a 1. Can you write that? No. Okay. So what we do is we understand we can't write that. So when I'm writing my interval notation, even though it's an open dot and it's not part of my solution, I still write it as my first value in my interval notation. Okay? But we do something to tell people that are reading this that there should be an open dot there. And what we do is on 5, right before it, we put a parenthesis. A parenthesis tells me that there's exclusion, meaning that 5 does not get included in my answer, but 5 point infinite number of zeros followed by a 1 does. That's really my first starting point. Does that make sense? Okay. Then I hit a comma. Okay. And now I'm going to drag this thing all the way through. And what would be the last value that infinity, okay, which is that guy, right? Okay. If I'm on a word processor, I'm on a typewriter, a lot of times they would just type comma INF for infinity, okay? But we're going to obviously use that symbol. I think if you type in, so you got that toolbar in WebAssign, I think if you type in infinity, it automatically puts that symbol in there, okay? But that tells me that my solutions start at 5, go to infinity, but they do not include 5, and they do not include infinity. Why do they not include infinity? Yeah. How come? I'll when I look at no, so like right there when I have that parenthesis around the infinity at the right hand side, that tells me that infinity is really not a solution to my problem. Does anybody know why? What's infinity? Give me a value for infinity. Okay, so if let's say you knew infinity. Let's say we knew a value of infinity. Let's just say it was 100. We knew that was infinity. Then you could add 1 to it, and you got 101, and now you have a new infinity, right? And what could I do to your new infinity? I could add one, so now 102 is a new infinity, right? Can we play that game forever? So we never be able to get to what infinity is, right? So Keaton said infinity is not a number, it's an idea. Exactly. Okay. Tomorrow, we will pick up with it. We'll fill this chart back in, and then we'll go through a bunch of examples of how we work algebraically with something and then present our answer in interval notation. Okay?